In a previous video, we did the crisscross method and learned how to name ionic compounds that only dealt with two elements, so a metal and a nonmetal. We're going to expand on that a little bit, something they may term ternary compounds, but really we're talking about three or more elements. And what we're often relating to is Table E and the periodic table. So if you have the name of an original element, or let's say it ends in IDE, usually you're talking about something, like over on this side, like fluoride, chloride, bromide, oxide, nitride, but that's not always the case. If it ends in ATE or ITE, if we look at this example, we have lots of these words, eight, we got an IDE there, so we have 8, 8, 8, 8, okay, 8, 8, ite, 8, 8. A lot of these end in ATE or ITE. And where you find those, if they end in ATE or ITE, you use Table E. So this is the New York State Chemistry Reference Table. You're going to use Table E. And as we look at some of these, some do have the IDE ending. So there are some exceptions. But if we look at a quick glance, a lot of these end in ATE. Not everyone, though. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 of these materials end in ATE or ITE. That's a great indicator that you're going to find your material on Table E. And these are called polyatomic ions, poly meaning many or more than one. And so when we look at it, each of them has multiple atoms in there, and usually it means multiple elements too. There's a couple exceptions. Peroxide, for example, is O2. Mercury can be dimercury, two mercury atoms together. And so there, in the previous video, I mentioned that there is an exception sometimes with reducing numbers, where you can't reduce certain things, but typically you are going to reduce. Now, what we're also going to talk about are these polyatomics. We cannot change any of these formulas. So for example, if we look at this one, MnO4, I can't ever change the MnO4. The only thing I can change is what I crisscross. And so we're going to talk about, and I kind of refer to it as the MC Hammer rule. Okay, MC Hammer had a song, of course, called Can't Touch This. And so when we do our crisscross, we cannot change or touch any of the numbers that are in here. These numbers are set in stone, we could say, because that's the actual ion. And I'm going to give you some examples here. So the concept is the same as what we did previously, in that we have to go back and forth between the periodic table using the oxidation numbers, which are in the top right. Again, I'm going to kind of go back and forth here. So remember from the previous video, oxidation numbers are in the top right of each box. And so our first example we're going to use is barium. Barium is +2. So when I do barium, Ba +2, but then chlorate is not just chlorine, but it has chlorine in it. And so when we go back to Table E, we have to, of course, find chlorate, and we want to make sure we're using the correct ending, ATE. And so if we look at our Table E, we see there's actually chlorite and chlorate. The big difference, ClO2 or ClO3. Is there two oxygens, three oxygens? And then there's perchlorate and hypochlorite. So there's all these different versions. Notice it looks very similar. They're all chlorine and oxygen, but we have only one oxygen, 2, 3, 4. That's going to, again, change the chemical properties. What we're looking for is this one right here, the chlorate, ClO3 and minus. The charges that we see on the top relate to the whole thing, and that's where, again, the MC Hammer part comes in. So the whole CrO4, that's the whole thing, has a -2 charge. The whole ClO4 has a -1 charge. Maybe the C2O4 is -2. Okay, if we go over to phosphate, PO4, the whole PO4 is a -3. It's the numbers at the top is what you would be crisscrossing. If there's no number like this, hydrogen is just a plus, ammonium is a plus, hydroxide's a minus, nitrite and nitrate are minus. That just means -1 or +1. If there's no number, it just means -1 or +1. Otherwise, there will be a number. So for example, 3 minus is really the same as -3. 2 minus, really the same as -2. Okay? So chlorate, this is where MC Hammer comes in. The ClO3, it helps, we can put it in a parentheses because the -1 or the 1 is going to crisscross and the 2 is going to crisscross. So I don't want to play around. I cannot touch what's in this. That has to stay the same. So when I cross it, Ba, and then in parentheses, ClO3 2 times. Okay, I'm going to bring my number down. I don't worry about the charge, I just bring the number down. So my number 2 comes down and my 1 comes down, but I don't have to write the 1 because, again, it's kind of like in math class, you don't write 1x, you typically just write x if you're talking about an equation. And so just like we did before, we cross the numbers. If we have the ability to reduce the numbers, we can reduce them as long as we're not touching anything in here. I don't multiply anything, I don't change the number out, I don't put the number after the CL or add it to this. I just bring the number straight down. That's all you do, is just bring the number straight down. Okay, let's look at lithium sulfate. Lithium is in group 1, it's a +1 element. Sulfate, if we look up sulfate, SO4 is -2. So my SO4, the whole thing is -2. Now, if you notice this time I put a parentheses there, I don't necessarily always need to have a parentheses because it really depends on where the number goes. But if you want to get in the habit as you start, you can, because if I bring my 1 down, I really don't need to do anything because, again, it's just a 1. If I bring my 2 down, I have to put the 2 there. So Li becomes Li2, and then SO4 just stays SO4. You don't necessarily have to put it in a parenthesis. If you want to put it in parentheses, you can. You wouldn't lose credit, but you don't need it because I haven't changed the number, where in this case I have 2 sets of my chlorate ion. Okay? Let's take a look at another example. Let's look at this one, copper 2 sulfate, and this will talk about where we might do a little bit different. So if you remember previously, we talked about the stock system in the Roman numerals. The Roman numeral tells you the charge you're going to use. So copper, Cu, +2, okay, the Roman numeral 2 means +2. If I was using Roman numeral 3, I would have used +3. Now, we already used sulfate, so that's familiar. So SO4, and this is -2. Now, a couple ways to look at this. We know that that's both the same. So if they're both the same, I already know they're going to cancel out. CuSO4, they have canceled each other out. If I want to go through the process and bring them down, CuSO4 2. Now, this looks really funny. This is the reason why we have to put parentheses. If I just bring my 2 down, now it looks like I have COSO42, and that would be very, very wrong. So if I brought my 2 down, Cu2, SO42, we would also then reduce those because they're the same value, and then I come back to my CuSO4. So again, that's the real reason for the parentheses. Again, if I would have brought this down without a parentheses, I would have had ClO32. So we need to make sure we're very careful when we're using our polyatomic ions. Now, these 3 examples, we had an individual element like a metal, barium, lithium, copper, with a polyatomic on the second side. Okay, the negative part was the polyatomic. We could also have the polyatomic be on the front side. And so if we look at another example here, let's jump down and we will look at ammonium hydroxide. Now, ammonium hydroxide has both. Ammonium sulfide, though, doesn't, but I'm kind of in the way here. So I'm just going to jump down here where we can have polyatomics on both the front and the back end. And so if we look at this one right here, ammonium hydroxide, we need both of them. Ammonium is right there, NH4 plus, hydroxide is OH minus. And so we have NH4, and really +1, and we have OH -1. If it's the same number, we don't really need to do anything and make more work for ourselves. We can keep it simple. They cancel each other out, cancel or balance out each other out, NH4, OH, and then we're done. I don't have to worry about parentheses because, again, I have not changed any of the other numbers, but there could be cases where you possibly do that. Let me just take a quick glance to see if there's other ones that start with a polyatomic on the front. Just doing a quick glance, it looks like most of them are starting with an element, but again, it can be the case. And that's, if you think about this chart these are all negatives on this side. They're all negatives up through here. And then we only have 3 that are positives. So we're not going to have as many potential that we would start our formula with, but a lot of them are going to be ending with. But sometimes you can have both. And so if we take another look, for example, if we scroll down here, we have platinum 4 carbonate. Platinum, again, the Roman numeral 4, so I know what I'm using, PT plus 4, and then we have to find carbonate. Carbonate is CO3 minus 2. So CO3 minus 2. Now I want you to notice there's a couple things that happen here. Because I have a polyatomic, again, the MC Hammer rule, can't touch this, right? When I bring my number down, when I bring my 4 down, I don't want to call this, when I, again, just kind of jump ahead here, PT, I don't want to call this PT2 CO3, 34 and bring that 4 down. This needs to be in parentheses. There's a big difference between CO3 4 times and CO34. Okay, big difference. Now, because the 4 and the 2 were here, these actually will reduce to 1 and 2. So my new equation becomes PT CO3 twice. Okay, we actually reduce our values if I have a number that has the ability to reduce. So if I have both even numbers, I can cut them in half, I can reduce them. And so I end up with PT and then CO3 twice. I have my numbers 4 and 2 that crisscrossed, and then they reduced. So we see a combination of different things. The key thing, again, when you have multiples, is you may need to use Table E. Again, the hint that I gave you in the beginning, if it ends in ATE or ITE, you typically are going to find it on Table E. Some cases, though, if it ends in IDE, there are some exceptions like cyanide and hydroxide, and there's a couple other ones on here like hydronium, dimercury, ammonium, okay, or permanganate. And so, well, even that as an ATE, but hopefully you get the idea that when you see things that have multiple elements, you're going to have to use Table E if you just get the actual thing, because you're going to need to go back and forth and not only name formulas, but you're also going to have to give formulas names. And so in this case, all we're doing in this activity is I've given you a name, just like in the previous activity, I've given you a name and you are going to figure out the formula. In other activities, I'm going to give you the formula and you got to go backwards and give me the name. So hopefully you found benefit from this. Again, the key thing, if it's ending in ATE, ITE, use Table E. If you are just using your typical element, you can typically only use the charge that's available unless it has something like these, the Roman numerals. Then the Roman numeral will tell you what charge to use. So Roman numeral 3 means I use a 3. Roman numeral 4, IV is 4. We talked about Roman numerals in a previous video. Okay, I would use the plus 4. As we scroll through this, we have 1s, 2s, and 3s. I don't think there's anything higher on this one. But you may see 6, you may see even 7 for some elements. So hopefully you found value and you're able to take formulas take the names and give the formulas using the compounds, using your reference table and using Table E. All right, take care.